Thanks a lot, Lucy. Really good to be part of this, and really inspiring presentations from everybody today. It felt like a really good treat. Let me see. So I'll talk about how we're trying to transform our practice and rethink the way we design. So I'll go through our journey so far, the progress we made, and exchanging knowledge and learning from and collaborating with others. We're a design-led practice interested in sustainability and regenerative design. And there is a preconception out there that the two don't go hand in hand. But previous speakers, I think, have shown that that's not the case, really. We're one of the founding members of the AD movement, launched last year, which raised awareness on our impact on the climate and biodiversity crisis, and proposed several ideas and goals to address that. It has become a worldwide movement with a significant impact in the UK and globally. So on our journey, we've realized that there are several kind of linked stages. The approach we took and engaging the team were key and led to a dedicated role within the practice. The bottom-up approach we had meant that there is a sustainability team in-house already. We're 85 staff practice. The sustainability team is made up of project architects who meet once a month and discuss how the practice can become more sustainable and more aware of the impact we have through our designs and practice operations. The top-down approach means that the directors have set up a succession plan in place, and the practice is now an employee ownership trust. As a practice, we are interested in moving from the idea of sustainability and minimizing the negative impact of our designs towards regenerative design, which makes a net contribution to the environment. So we want to position ourselves in this kind of safe and just space for humanity that Kate Raworth was showing in her donut economics diagram, whereby there is a social foundation, but we don't overshoot the ecological ceiling that the Earth is providing. So practically, we started by engaging the team. We organized a full away day, a full day out for the entire office to debate sustainability and regenerative design solutions. We had speakers in and workshops discussing practice operations and 4 main kind of design themes that we went through. And basically this fed into our toolkit, and we kind of had a document that came out of this that inspired our project procedures, project reviews, and sustainability reviews in-house. We also installed environmental sensors in our offices to record temperature, relative humidity, as a way to raise awareness about the importance of engaging with our environment and to see how ventilation temperature can vary and can influence our behavior. So anyone in the office can just walk past these and wave their hands, and they show either a green or red or amber light that checks if the comfort levels are within their limits. And also you can see the data on an online platform. Another way to engage the team was to do an office carbon footprint, which actually helped us to understand our own carbon impact and ways to minimize it. It turns out our carbon emissions linked with electricity and flights are quite significant. So we looked at ways to minimize this alongside encouraging staff to take more kind of energy efficient commuting means. All this might be way different this year with everybody working from home. However, we realized also that the design impact we have compared to the office carbon footprint is way bigger if we think of the number of projects we deliver and the fact that they all basically emit carbon emissions for 60-year lifespan or more. However, the carbon footprint, the office carbon footprint is a great tool to raise awareness, as the premises are actually a great way to set the culture in the office for both staff and the visitors, and to show that we're committed. So our progress so far, implementing what we found during these explorations, we know that there's an existing refurbish ethos and innovation in the office. We've set some targets that we are aiming for, and then we thought about how do we get there? What are the ways we can figure out how to get there? And we're still kind of trying to figure this out. So we've always been involved in refurbishment projects. We're trying to keep and show the beauty of existing structures, expand existing structures. We've always been interested in innovation, reducing embodied carbon, using healthy materials, exploring prefabrication and offsite manufacturing. We're keen on using timber structures. And on a recent competition, we had a chance to try our hand in employing a range of regenerative design measures, and that was really good fun. We didn't win it, but it was really good as an exercise for the practice. The targets we have set, just like James was talking about, it's basically LETI, RIBA challenge, and we're also interested in the Living Building challenge because it's a well-rounded standard that looks at both kind of ecology, beauty, materials, net zero carbon, all in one. We have a LETI Pioneer Register project, which is a challenge for ourselves to see if we can get there and to basically explore design solutions within our team. And the key thing we found is that empowering the team and providing support through training is key to develop work habits on reporting on 3 main targets: energy use, embodied carbon, and potable water use. Organizing sustainability workshops with the clients from the start of the project to discuss project aspirations, and to develop this autonomy in sustainability and regenerative design decisions, whereby every project architect can become comfortable with the metrics and to discuss environmental design solutions with any of the consultants. So we started by organizing a two-day training for a lot of our staff into Passive House principles, Passive House planning package, software, and design PH, which was very good because this is an excellent tool for energy analysis, as described in the previous presentation as well. And we've started a series of quick environmental analysis in-house using HBERT that Joe, Jack, and Louisa were talking about earlier regarding embodied carbon, operational energy. And we also want to use some moisture movement analysis in-house, just because this is particularly critical for refurbishments with internal installation. So all of this have fed basically into our design toolkit that we put together, and we're now testing, looking at 10 key parameters plus knowledge sharing and POE, post-occupancy evaluation. And it starts with passive design and fabric first, and then looking at net zero carbon operational, embodied carbon, waste and circularity, low energy systems and renewables, biodiversity, water use, health and well-being, adaptability, and community and amenity. And we've basically started to do an investigation into targets and benefits for each one of these. And then we feed this into our toolkit, and this becomes our kind of reporting on progress at regular reviews at each design stage, and reporting on the 3 key elements: energy intensity, embodied carbon, water use. We use the Regenerate tool for waste and circularity workshops. This has been designed by Sheffield University and ACOM. It's a free Excel-based tool, and we found it to be really good to discuss circularity. And we look at creating an integrated process within the practice, and trying to have this as a collaboration with the client and consultants, starting from the early design stages, workshops and setting sustainability targets, moving on into implementing these into design and on site, and then soft landings and post-occupancy evaluation. We also carry out regular project reviews and audits to discuss sustainability targets. We found that collaboration with consultants is actually really critical. We learn from them a lot. This is an analysis done by Whitby Wood Structure Engineers. We've also had Andrew Weil, who presented his carbon report earlier today, to come speak to us, trying to present this type of structural options comparison to our clients on our projects. Most of them do this now, to look at embodied carbon, and then to optimize whichever is the final chosen option, to optimize that in terms of floor to ceiling spans, material use, and so on. We've also started to ask for accurate energy models from our M&E consultants, trying to move away from just the Partel compliance models. And we've started to set up a reporting template based on the RIBA POE primer for post-occupancy evaluation studies, which are just kicking off at the moment. In terms of advocacy and learning from others, we're now involved with drafting a practice guide for AD signature practices. If you'd like to participate, please do send an email here. There's a draft document that we are working on now, which is focused around AD's 11 goals. And we're looking at exploring practice operations and design work, and providing easy wins, resources, exemplars. It needs to be further developed, and the goal is to make it useful and relevant for practices of all sizes and working in any sector. So a summary, quick wins: engage the entire team, support and train the staff, collaborate and ask for help, workshops with clients, and reach out to others and share resources, which we found really useful. Like Architects Declare has an event in November, and Lady and I can do a lot of work where we can both have a contribution to and also learn from.
And I think we're going straight to Paul now. Thank you so much, Diana. I'll bring you back in for questions after Paul's talk. Thanks so much.
Okay, so I'm going to be sharing a little bit about lessons we've learned from working on our own studio. And we signed up to the 2030 Climate Challenge, and last Christmas, I came back from the break, and I think as often the way as a director of a practice, you reflect. And I felt quite convicted really that we wanted to do the right thing, and we talked about doing the right thing. But to be frank, we weren't necessarily doing the right thing, and we hadn't really put into practice what we were wanting to preach to our clients. And so we made the big decision to see if we could refurbish our office and hit the RIBA 2030 climate with our own building. Little did we know that a few months later we would go into lockdown, and it would actually prove to be a great time to do work on a building, because obviously we were all working from home. And one of the things we were grappling with is, well, you know, what is the difference between the RIBA 2030 climate and being carbon neutral? And I think one of the things we've realized going through this project is just how much our clients only really think about carbon neutrality. As far as they're concerned, getting carbon neutral is something they understand. And so one of the things we've needed to do is get our own heads into the differences, so we can really be more intelligent in the way we explain to our clients what true environmental design is all about. So what were some of our goals? Well, one of our core goals was to achieve the RIBA 2030 Climate Challenge, but we also recognized just how much we needed to learn. And I think we knew we had a long way to go. I think as we got into it, we discovered just how much we didn't know. It's quite a humbling process as an architect who's been around a little while to realize just how much you still have to learn. But we have learned a lot of lessons, and I'll hopefully share some of those things today. The other part of it, of course, was an opportunity to rebrand our own premises, and in that to practice what we preach. And I guess to demonstrate to our clients our values. And we hope that that will in turn attract the kind of clients we want to work to us and give us more opportunities to push the boundaries a bit on environmental design. One of the key things though, and it's something I'm going to touch on throughout this presentation, is it was essential that we created a viable property development. Fundamentally, this was our offices, and we're the client and we've got to pay for it. And one of the challenges is we're based down in Totton near Southampton. It's a nothing special town in the south of England, and rental values where we are about £18 a square foot. And that's me being ambitious on what generally is about £15 a square foot, assuming that a decent bit of architecture and carbon neutrality might actually raise the rental value. So it was a real challenge for us to deliver a scheme at a very low price point. And to put it in context, our budget's just under £400,000. And you'll see we're trying to pull off a reasonably big amount of work. So this is our existing offices. We bought the building 4 years ago. It's a shed on the edge of Totton, and we've got some parking. It's a brick-built former church. It's an uninsulated metal roof. There's plenty of room for improvement on the existing building. And the basic concept was we wanted to add about 50% more floor area and basically add a story on top of the building. That was the basic concept. And so, as was our historical way of doing things, we set into it with great gusto, great enthusiasm. We designed ourselves the scheme that was our dream office. And we were collaborating with Mesh Energy, who were our energy consultants on the project. Very exciting, really pleased with what we had ended up creating. We'd got to the point where we were hitting the RIBA 2030 climate challenge targets. We had a building that was led primarily through a CLT structure, and therefore, as a general heads up, if you ever want to hit the embodied energy targets, the simple way is work with CLT, because you get a carbon positive material in large quantities, which can offset a multitude of sins. We then got into the costings, and we continued to sort of value engineer, and we got to this really difficult, challenging moment where it was becoming clear to me that we just could not fundamentally justify, in the current circumstances, committing every penny in the practice into a project, which, although we loved it, it would fundamentally have pushed us too far. And in the end, nothing more pragmatic than the maximum deposit which we could achieve with our lending criteria became the driving force, unfortunately, for the project. So we looked to I guess our core values, and we fundamentally, although we were very proud of this scheme, Snug is a design-led and commercially savvy practice, and we pride ourselves on trying to get that balance right for our clients. And so I guess we had to go through that pain ourselves and learn from being client. So we went back to basics, and we basically realized we could actually get a mezzanine into the existing building, which would achieve almost all the floor area we needed at significantly lower cost. And then we went about the process of seeing, okay, can we still get this more pragmatic scheme at this now much lower price point, because we were building less floor area, so we had less economic value, and then we had to tighten our kind of cost plan. This is the scheme which I'm going to sort of talk through some examples and kind of drill into one or two little bits of detail just to help you hopefully learn some of the lessons that we've learned. So the scheme, at the end of the day, is going to be our home. Primarily, we're fitting a mezzanine and this new dormer on the top, and creating what literally will be quite a snug office, hopefully giving us the space to grow to about 25 to 30 staff. And that's the basic kind of scheme, just to give you a feel of it. But the other part of the project was not just the fit out of the building. We wanted to sort of do some work to our site, to green up the street, to improve the well-being opportunities within the site. So we've got a little allotment out the back. We've got a new seating area for lunch outside. And we're obviously fitting things like electric car charging points and other things as well. But the reality is all of that also adds quite a lot to the cost, but we feel is really important to the overall package. So let's kind of get into some of the things that we learned from this. Well, the first thing we learned is that compromise actually is quite important. And as I've already said, we have to be commercially savvy on this. It's our own building, it's got to stack up. And beggars can't be choosers. And the bottom line is we had a finite budget. So the development appraisal did become a really important part of the process for us. And I think actually we've learned a lot more lessons because we had to work to such a tight budget. And so we've discovered what was right for us. And so we're pleased with where we've ended up, and we can't wait to get on with the project now, which we hope starts in about 3 weeks' time. So some of the key things we discovered, there is an awful lot to learn. There's an awful lot of technical information. There's a lot to learn in terms of process. And there's a lot to learn in terms of collaboration with the energy assessor in particular, learning to speak the same language, learning to get the best out of them. And I'll touch a bit on that as we go along. One really interesting revelation for me was that the biggest problem we had was we're a Mac user. And I'll explain what I mean by that in a moment. But unregulated energy demands are really critical when you're dealing with an office project in particular. The importance of marginal gains, really important. Small things make a big difference, and particularly because we very quickly get to the easy wins, the low-hanging fruit, so to speak. But the problem is that's just not good enough. And then you have to find much, much harder, smaller changes that ultimately get you to the 2030 line. And I also discovered that embodied energy is a dark art, and we'll unpack a bit of that. So I'm going to focus on operational energy first. That's where most of us, I guess, historically thought about environmental design. That's what most of our focus was about. And the fabric first moving through to offsetting is the kind of journey we're used to going through as architects. And the target for a commercial building, for a non-domestic building, was to get under 55 kilowatt hours per meter squared per year. I had no idea what that meant when we started out. I didn't know whether that was hard or easy, but to put things in context, our current building, when we analysed our existing energy use, was coming in at 250 kilowatt hours per metre squared per year. So just over current benchmark, which in reality is not too bad for a building that hasn't even got an insulated roof. So it made me think, goodness, it's maybe not so hard. But then we discovered there was still a long way to go, and driving down to the bottom is difficult. We also went through a process of optioneering. So we got the energy assessors to work with us to run a range of fairly significantly different options quite early on. And we looked at various elements of value engineering. So for example, did we or did we not re-insulate the flat roof on the building at the back? We also got them to run the model based on the whole thing being a new build. And what was interesting is that we could only get under the 2025 target with a gas boiler. We could get under the 2020 target. We could get under 2025 with an air source heat pump, and we could get to 2030 if the building was a new build and we knocked it down. But unfortunately, that wasn't a viable option. And so we then went through a process of really trying to drill down to how on earth do we get that last bit to get us under 2030. One of the things that became apparent is that even with a new build project, it was this issue of regulated energy demand versus unregulated energy, which was the real kind of nitty-gritty problem. And even on the new build option, we couldn't quite get under the 55 threshold unless we discounted only accounted for the regulated energy use in the building, at which point we suddenly dipped under quite comfortably. And so I'm going to unpack a bit about that in a moment. But the other thing we were also trying to do is drill down to, are we achieving carbon neutral? Because I still hold that that is what most of our clients think of. And from a brand point of view, it's the easy message. And they are not the same things. Hitting 55 kilowatts of energy use is not the same thing as being carbon neutral. And it took me a while to get my head around that. So one of the things that we then did was drill into how do we just get carbon neutral without spending more money than we need to? So we were playing around with 56 PV panels, 60 PV panels, 66 PV panels. And what became apparent is that we couldn't get enough PV on the roof to bring the building under carbon neutral with a gas boiler. And that in itself was very interesting to me. It basically made the point that a single story building would not become carbon neutral because we just could not push it hard enough to get to that point without the use of an air source heat pump. So we committed to the air source heat pump, and that's part of the journey as to how we got to the target. But just to give you a feel here on some of the challenges, you start to sort of pursue these marginal gains. So air tightness, we're refurbishing an existing building. It was unrealistic for us to do the supposedly easy thing on paper within the spreadsheet of putting one in. We just weren't going to hit it. And so, and we certainly weren't going to hit it cost effectively. And so once you're not hitting one on the air tightness, you're already going to struggle. U value, we could push the U value on the roof, and we have done because we're replacing the roof and we're completely insulating it. But the walls have an existing cavity and we're going to fill that cavity, but we couldn't afford to overclad or insulate on the inside of the walls. So we were never going to get the walls to the U value we needed. And the floor, well, there was nothing we could do to the floor. and the floor was always going to be really poor performing. So the problem we had is with a refurb, there was just fundamentally lines in the sand we just couldn't cross. So we worked our way through fabric first as far as we could go, and then we started to look at the low energy heating source with the air source heat pump, and then we came on to maximizing and fine tuning the amount of renewables that we could fit on the roof. And what became apparent in all this iteration is that you really are hitting the point of diminishing returns when you get towards 2030. That target's not been set without someone having processed quite carefully, setting a reasonably high standard. It's quite easy to get to 2020. It's relatively easy to get to 2025. It's really difficult to get to 2030. And of course, the cost doesn't go up linear. It goes up exponentially. So it was becoming very difficult for us. And one of the things we realized was, because we're Mac users, and I'll come on to this, we were going to have a real problem. So the way in which the energy assessors measure, they are required to put in the unregulated loads on the building. So the operational energy is the energy required during the entire service life of a structure, such as lighting, heating, cooling, and ventilation systems, and operating building appliances. And the critical question is, does that include your operations within the building, or is that just talking about the building management system, for example? So we then drilled into this. Okay, what does that mean? If you put the max in, what's the problem? How bad is it? And the Mac really turned out to be the problem. So just to give you a flavor, in the standard formula, the CIBSE TM54 standard assumption was 10 watts per meter squared for energy use on an office. We then said to the energy assessor, and this was my mistake, oh yeah, we use max. And by the way, here's the layout that we're proposing. So he goes away and counts up all the computers, puts that into his spreadsheet, and all of a sudden we're completely blown out of the water. It turns out the max used between 18 and 74 watts per meter squared. So we're talking significantly more energy use. And of course, our max are often running at full pelt, and therefore we really are at the top end of that energy use. So we're suddenly seeing our operational energy, our unregulated operational energy, going up by as much as 7-fold. That is a big problem. And at the same time, we were drilling into, well, how far can we go in terms of achieving a carbon neutral operation? Because what I'd really like to try and say is that we haven't just got a carbon neutral building, but we've actually got a complete operation as a practice, which is carbon neutral. And one of the little things you can have for free here was, it was astonishing to discover that all the mileage on our 2 pool cars, which we reckon was about 12,000 miles typically on our pool cars, all that mileage only came to 10% of the electrical use, or 3.8% of the energy use of our current operation. And when we get to being a well-insulated fabric first building, our car usage is such a small proportion of our energy use in the building that it made no discernible difference to our end calculation. So one of the things I learned is that cars really don't use that much carbon. The worrying thing is buildings really do. And therefore our job is very important, and we need to take all this very seriously. So I guess a lesson is, if you want to get through the formula and you want to just tick the boxes, don't tell your energy assessor too much information. It pays for the energy assessor to use generic data. If they start counting your max, you're in trouble. The very interesting thing is, that doesn't take into account what will happen if someone in the future changes to PCs and all of a sudden the energy use drops. So there are some interesting questions here for all of us, I think, as designers, around what is an appropriate assumption when you're designing a speculative office building? Is it fair to be penalized by being a Mac user? And how does that work? So in the end, the work we did at stage 3 identified that the building could comfortably hit Part L, and with the air source heat pump, we could get to carbon negative, which was great. The headline was achieved. The study found that it was possible to meet the 2030 Sustainable Outcomes Guide aspirations, but the achievement rests largely on the efficiency of unregulated energy use. And so we basically got there on a technicality, I guess. So it's important to note that operational energy, including all energy consumption devices and systems within a building, is what effectively constitutes evaluating your operational energy performance. And there's a real challenge, I think, here for us to be able to report early on enough in projects really what is going to be the future energy use of that building and what kind of operations are going to go on it. So yes, we follow that fabric first approach, but the efficient systems is actually much more difficult to pin down on the unregulated side if you don't know what the client's finally going to do with the building. So we all need to be able to build up rules of thumb, Therefore, post-occupancy is really important to be able to evaluate existing buildings so we can feed more accurate data back into the models and make sure we're being honest and open about what's really going on. So that was a little bit about operational energy. Just a very quick thing on embodied energy. I say it's a dark art. It really is. So if you look at this little table here, what will probably stand out to you is the aluminium there at 170. So the aluminium has got a significantly higher embodied energy. And what you might note there is that the in situ concrete is 1.9. So looking at that, you'd think in situ concrete, brilliant, very low, aluminium, very high, don't touch it with a barge pole. Well, you'd be wrong. And the reason is because in a building, we use a very, very large amount of concrete, which of course is extremely heavy. And so in the end, embodied energy is a product of weight, not just a product of how much carbon is in the material itself. And so the reality is on a typical building, this is a typical one-off house, you might end up using only a small amount of aluminium, and therefore actually it contributes very little to your embodied energy. Whereas concrete, you will end up using a very large amount of it and it is very heavy, and therefore it will contribute a large proportion of your embodied energy. So one of the things we discovered is that, and yes, you can tame your engineer and encourage them to seriously design out extra concrete in the ground, you are doomed before you even start. And no amount of minutiae tweaking in the superstructure and in the fabric and cladding is fundamentally going to get you over the line if your engineer is not working hard on the frame and on the foundations. So in situ concrete, don't be deceived by that 1.9. It's not a great material when it comes to embodied energy. So just to give you a little example of how we sort of tried to go about engineering marginal gains and engineering embodied energy down sort of one element at a time within the building. And I just want to focus on this large window at the end of the office, which was always crying out for being value engineered out. And we've discovered how to hold on to it. So the first thing we do is we try and get the data, and we managed to save 50% of the embodied energy on this window. And we managed to bring the cost down by 70% at the same time, which was really satisfying. And we did that just by redesigning the mullion distribution across the window. So the key data here is that glass has an embodied energy of 12.7 megajoules per kg. And very interestingly, up to 2.4 square meters is 4 millimeter glass, and that's 10 kilograms per meter squared, so 127 megajoules. Under 6 square meters is 6 millimeters, and then over 6 square meters is 8 millimeter glass. So if we go for a very large pane of glass over 6 square meters, we're talking about 254 megajoules per meter squared. And so what we did was we went through a process of seeing how close we could get to the 2.4 square meters. So we were certain, the critical thing being under 2.5. And we basically ran the analysis on a series of window configurations involving the 2.4 square meters. Then option 5 there, which was using the 6 millimeter, and then option 6 there, which is using the 8 millimeter. And then option 4 is a sort of hybrid between the two. Well, the 8 millimeter was 8,000 megajoules of energy. The 6 millimeter, 5,800, and the hybrid solution, 3,708. What was really interesting is when we got the subcontractors to price this window, this one was 5K, the middle one was 10K, and the supposedly glorious, free from any mullions, was £15,000. So there was a decision to be made. You know, as a designer, this is a classic decision we make all the time. And the bottom line is we felt there was enough joy and enough architectural delight and enough quality, and more importantly, the same amount of daylight and the same amount of glass, to all intents and purposes, coming through the bottom one, but it was significantly cheaper and less than half the embodied energy. For us, that was the right choice. It was then only an extra 1,700 quid to go triple glazing on the lot and to bring our U value down to 1.0. So in the end, we were able to really hit all the figures we needed by getting ourselves deeply into the design of that window. And when you start doing that across a whole of a job, it's a lot of time and energy. And so we as a practice are constantly trying to build up rules of thumb. So we ended up on the technicality, hitting both of our targets, carbon neutral, no problem, 2030, definitely on a technicality. And that's the approach we went through. We did all the things that one normally does, and made some choices and compromises in the journey. So we have achieved a carbon neutral operation. but we achieved 2030 on this technicality. And I guess the reality here, being honest with you, is if our true operational energy use as architects is applied, we don't quite make it. And it's a challenging thing to discover that it was our max that in the end held us back from achieving our target. Maybe a conversation we need to have with them. So thank you very much, and look forward to taking any questions.
Thank you, Paul. And could I bring back Diana as well? I think we've got time just for a couple of questions. I suppose what's quite interesting about these two talks is really what struck me really was the role that targets have played, and it's really reassuring to see the RIBA's 2030 climate challenge targets being used as a design decision-making tool. And you talked about different strategies for kind of holding yourself to account, whether that's through kind of design review processes or optioneering. I mean, how important do you think these targets are, or do you think you end up with kind of the unintended consequences, as you said, Paul, of kind of getting through on technicalities?
I think if you don't measure, you kid yourself. I've spent the last 25 years thinking I was a sustainably conscious designer. I mean, I listened in those lectures at college where you face south and you can, have a well-insulated building, and it's build tight, ventilate right, and all those things. But when you measure it, it's like saying, I go riding and then I turn my Strava on and I discover I'm not quite as fast or fit as I thought I was. And I think we have to be accountable, and measurement is the only method for being accountable.
Yes, yeah, I agree. And I think the tools we use for measuring need to we need to use the right tools. If we just go for, partial compliance stuff like SAP or SBAM, that's not going to show any kind of real, that will not cut it. You need to do PHPP or TM54 or thermal modeling, proper analysis to get a credible energy function. What Paul was talking about, the type of energy use from computers. Yes, we need to be aware of unregulated use and making assumptions as to who will be using the building, how many appliances or computers or equipment will go in there. What's the power consumption? Between power or standby. I'm sure there's a middle ground that needs to be used rather than the top maximum, because I think that happens very rarely.
Thank you. And a great question here from Hattie Hartman. Given the journeys you've taken, your practices have taken over the last 6 to 12 months, are you optimistic about the profession being able to undertake the step change in the next decade? Maybe Paul, do you want to take that first?
Yeah. Well, I'm an optimist, so I'm always optimistic. But I think, to be quite frank, if you can achieve it in Totton on £18 a square foot rental values, then there's really no excuses. And I think for us, that was part of what I wanted to do, was really find out, could we do it? But as I say, for us to get there not on that technicality would be really quite expensive. And the bottom line is I'd probably have to subsidize it to the tune of 100 grand. And I just don't have the ethics to spend that kind of money, and how many of our clients are as ambitious as we are? So I am concerned, if you like, on the viability side of things. It's always the viability that comes back to bite us, but the technology is coming down in cost all the time. And I think certainly with a new build, if it's regulated, then our clients will achieve it. Whether the market can cope with it, I think needs a bit more work on the economics.
Diana, what are your thoughts?
Well, I think this event is actually showing that there's so much energy and enthusiasm and commitment on the part of architects and their consultants to reach these targets, and everybody's aiming towards that. And when you see projects like Goldsmith and various other low energy projects, pioneered by town or in UK generally, you realize that to low energy levels cost effectively is not something that's out there utopia. It's being done. So yes,